So this was number 17. The first thing you really want to find is your axis here, which is negative b over 2a. In this case, that's negative 12 over 2 times negative 6. So we end up with positive 12 over negative 12. So my axis is y equals negative 1. All right. So then we're going to graph that y equals negative 1. Remember, that's not actually, we dash that to indicate it's not part of our graph. It's just helping us to graph the other pieces. So we're going to graph that right there. The next thing we do is to find our vertex. So we take that negative 1. That's going to be the x value of our vertex. So we know we're going to have a negative 1 there. To find the y value, we literally just plug that in to my equation. So I have negative 1 squared, which is positive 1 times negative 6, negative 12 times negative 1, and then minus 1. So I have negative 6 plus 12 is positive 6, minus 1 is 5. So I go negative 1. All right, and then my y-intercept is really just my c. So my y-intercept is just my c. And so that value is going to be 0 for the x and negative 1 for the y. So that's going to be right there. Mirror that guy across. And then if you connect those, you will have your... All right, so for this one, the question is saying, find the minimum value. So they wanted you to graph the function, but they really wanted you to find the minimum or the maximum value. So first is you have to decide, is this going to have a minimum or a maximum? So is this guy going to be pointing up or pointing down?
Pointing down, up.
Up, so you have a minimum, right? You have a minimum here. To find the minimum, yes, you just find the vertex, right? And so the vertex here is going to be the negative b over 2 times a, so you get 4 over 6, or 2/3. And then you have to plug that in. So you just say 3 2/3 squared minus 4 times 2/3 minus 2. 2/3 squared is 4/9, right? And then your 4/9 will cancel with that 3, by the way. So you end up with 4/3. Minus 8/3, and then change this guy to 6/3, right? And so we get negative 10/3. Yes? And so your vertex happens at 2/3, negative 10/3. So negative 10/3 is actually your minimum because your y value determines what's your highest and your lowest. So your minimum is actually negative 10/3 there. Look at this. It says the equation for the motion of a projectile fired straight up at an initial velocity of 64 feet squared, or feet per second rather, is h equals 64t minus 16t squared, where h is the height in feet and t is the time in seconds. Find the time the projectile needs to reach its highest point. How high will it go? So they have given us a quadratic here, right? They've given us h equals negative 16t squared plus 64t. All right. When they say reach its highest, which way is this particular parabola pointing, up or down? Down, which means I will have a maximum. So when it's asking me for my highest value, it is asking me for my maximum. It is telling me that time is in seconds, all right? And that h is my height. So this is my y value of my vertex. T is my x value of my vertex, okay? So it says find the time, x value of my vertex, and how high will it go, y value of my vertex. It's really just asking me to find my vertex and then decipher it. And so I'm going to say negative b over 2 times a. Well, that's negative 64 over negative 32. That is 2. And according to them, that is time in seconds. So that is 2 seconds is the x value of my vertex. How high will it go? Well, I'm going to take that 2 seconds And I am going to plug that into my equation. How high it will go is going to be negative 16 times 2 squared plus 64 times 2, right? And so I'm going to get negative 16 times 4, right? And then that, so this is going to give me 64. Well, 64 what? This is height in feet. So now I'm going to say 2 seconds, and my highest will be 64 feet. It's simply asking for my vertex there. So in this case, we have this particular form, which they're introducing here. You do have to know both forms, standard form and vertex form. Graphing, all right? When H is positive, the graph shifts right. When H is negative, the graph shifts left. When K is positive, it shifts up. When K is negative, it shifts down. The key here is that the vertex is HK. And so if you have it in vertex form, you have the axis of symmetry, which is your H. And you'll notice I'm not using the negative in front of it. So it is the opposite of what you see. If it is minus H, it's going to be a positive H. If it's plus H, it's going to be a negative H because your original equation has a negative there, okay? So your vertex is your axis is H, and your vertex is HK. And so when you have it in this form, you actually have your axis and your vertex handed right to you. All right, to find your y-intercept, you literally just plug in a 0 for x, just like you would any other time you're trying to find a y-intercept. All right, so let's look at this. Standard form. All right, so normally in standard form, you would have to do negative b over 2a. So for this first one, you would say negative 4 or negative 4 over 2 times 1. So your vertex would be, or your axis would be at 2, right? And you can see that your axis is at 2, right? So your H here is 2, just like you would think. You can see that it's minus there. You can also see that if you plug this back in, if I get 2 squared, that's 4, minus 8, negative 4, plus 4 is 0. There's a plus 0 there, so my vertex is going to be at 2, 0, which is what would happen there. And so that's what's happening all the way across here when you are doing this in standard form. I want to point out one thing. When you start having coefficients, if I were to put negative 12 over 2 times negative 3, I am going to get a 2, right? Negative 2 rather, which is what you see right here, okay? If I plug that back in, I am going to get a 4, so 2, 4. And you'll notice the A remained the same. That negative 3 just goes in front. So if I'm converting from standard form to vertex form, I can just find my HK and plug it in, and then put my A in front of my parentheses. You'll notice the negative 3 and the negative 3 went there. All right? And so when you're doing these, you're going to find, if you're converting, find your HK using those, and then just pull that A and put it in front of your parentheses. If I'm going the other direction, you can literally just FOIL and distribute, right? So going the other direction, you just simplify. FOIL your group, distribute your coefficient, and simplify it from that direction. But if you're going from standard form to vertex form, which sometimes they ask you to do, you're just going to find your vertex and then pull your A out in front, which you're going to do a couple of those. Graphing from vertex form is really simple, actually. Graphing from vertex form is way easier than probably graphing in standard form. So for this, you're still going to find your 3 pieces. You're going to find your axis, except it's much easier. Your axis is just going to be your x equals 2. It's right there. They just give it to you. And so you're going to go to 2, and you're going to graph it. All right? To find your vertex, you do the same thing. You just do your HK. And so in this case, my vertex then is also handed to me. My vertex is going to be 2, 3. And so I'm going to go to 2, 3 and graph that. My y-intercept is the one that I have to actually calculate. And so we say negative 1/2 0 minus 2 squared plus 3. You do have to do order of operations. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times 1/2 is 2, and then 2 plus 3 is 5. And so I do have to actually plug this in to find my, oh, that's a negative, by the way. Negative 2, sorry. And that's going to be 1. So 4 times negative 2, negative 1/2 is negative 2 plus 3 is 1. So I do have to calculate this guy when I do that. But other than that, that's the hardest piece, is finding your y-intercept. And then just graph it. All right. So axis and vertex are just handed to you with your h and your k. Y-intercept, you just plug it in and do order of operations. Okay, make sense? All right, so go ahead and just like we graphed from vertex form, you should be able to be given a graph and give me the vertex form.
No.
And so in this case, I mean, obviously they gave you that, but I mean, just, over 3 up 4, that point is 3, 4. So that tells me then that I have, oops, move that down, that I have y equals some number, a, and then x, and I'm going to say minus 3, because that's a positive 3, plus 4, okay? So then I need to find my a. All right, you can find your a by doing any other point on the graph and plugging it in for x, y, and solving. So let's say I want to take a point that they've given me here.
Could you use the vertex?
No, you already have the vertex, so
You can plug the vertex in.
no, that's not really going to help you. You want to pick another point. You want to pick a point where it definitely crosses on an XY. Like I wouldn't estimate and say, oh, well, this is about, 1 3/4. Like, don't pick him. Okay, pick one that crosses directly on it. So they have chosen 5, 4. So we're going to put the 5, 4. The negative 4 is my y value. A, and we're going to say 5 minus 3. That's my x value. So we're really just plugging in any xy that's on that graph to solve for a. And then you're just going to do, basic algebra solving, right? So 5 minus 3 is 2. 2 squared is 4. We're going to subtract our 4 over and then divide by 4. So we have negative 8. So a is going to equal negative 2. By the way, when you do this process, how do I know that that's going to be a negative, that my a is going to be a negative? Why should I automatically assume? Yeah, because it's pointing down. So that's just a quick check of, did I do it at least partially right, okay? And so if they want the actual equation then, plug your a back in and leave your xy alone, right? So we're going to say y equals, we're going to use this a, negative 2, x minus 3 squared plus 4. That is the equation for that graph. So basically it shows you what happens in vertex versus standard form. So we have standard form up here that we have looked at. And then we have vertex form. Straighten this a little bit. All right, so with standard form, it's pretty simple. 0C is my y-intercept. My x value of my vertex is negative b over 2a. And my y value of my vertex is what happens when I plug in negative b over 2a. All right? For the other one, I actually have the h and the k. So h is my x value, k is my y value, my vertex. And my y-intercept is still 0, but I have to plug it in. So I have to plug in as 0 and then calculate it just using order of operations, right? And so I have to calculate this, whereas normally I don't have to calculate it here. All right, and so they kind of hand you different pieces depending on what form you have. All right, if you have standard form, you are going to have to do negative b over 2a, plug it in, and get your axis and your vertex. You're going to have your y-intercept. For vertex form, as it sounds, you're going to have your vertex handed to you, and then you're going to have to calculate your y-intercept. And then we're going to convert, just like we talked about. Look at the top of page 151, or 251 rather. So in this case, they gave it to us in standard form. They want us to write it in vertex form. In order to write it in vertex form, we have to find the vertex. And so we're going to do what we did in the last section to find the vertex. We are going to say, well, I have negative b over 2 times a. All right, negative b over 2a, and they were nice and gave us a fraction. All right, so we have negative 10 over 4, which is negative 5 halves. All right, negative 5 halves. And then to find the y value, or the k of my vertex, I'm going to plug that in. So I'm going to say 2 then times negative 5 halves squared plus 10 times negative 5 halves plus 7. All right, negative 5 halves squared gives me 25 over 4, which is going to cancel with that guy. So I get 25 halves plus, this will actually cancel as well. Negative 25 plus 7. You can redo this if you want to a mixed number, or you can just get them all in improper fractions, whichever one you prefer. So it doesn't matter to me. You end up with 5.5, by the way, negative 5.5. But this is going to become negative 50 over 2. This has become 14 over 2. So we get negative 25 plus 14. And we end up with 11 halves, or negative 11 halves here. So we have our h. We have our k. All right. So negative b over 2a, plug it in. And you have your hk. And so then you're just going to plug it into vertex form. Now, your a stays the same. They gave us our a to begin with. That's the 2 in front of the x squared. So that's going to go outside here. We're going to say x minus. So my h was already a negative. So I would say plus 5 halves, or 2.5 squared. And then my k is going to be a negative. So minus 11 halves. Or if you do decimals, which is fine, you would have 2.5 here minus 5.5 there. Either one is fine. But for vertex form, you just find your x and your y of your vertex using your negative b over 2a and plugging it in. And then those go in the hk places of your vertex form. Your a, whatever they gave you at the beginning, is going to stay your a at the end.